Alright guys, for today's lesson, your essential question is how do we calculate the trig ratios in right triangles? Alright, your vocabulary is sine, cosine, and tangent. And hopefully those three vocabulary words are very familiar to you as SOHCAHTOA. Maybe Chief SOHCAHTOA, doesn't really matter. That's how I learned it. Three that might not be so familiar to you are cosecant, secant, and cotangent. And we're going to talk about those as well. And just to kind of give you some updates, you will have a quiz over this material and eventually a test, okay? All right, let's jump right into it and get your vocabulary out of the way. Now, for today, we're only talking about right triangles. So if I were to just draw any old right triangle, the first thing that of course has to occur is that in a right triangle, you have to have a right angle. And you do know that when you have a right angle, the side that is opposite that right angle is what we call the hypotenuse. And then it's also got two legs. They could be legs that are the same length, or there could be one short leg or one long leg. But basically, they're both legs. All right. Another thing that's very crucial is that if you have one 90-degree angle in the right triangle, then the other two angles are acute and they are complementary, meaning that the other two angles also add up to give you 90. Because remember, a triangle has 180 degrees in it. Now, this is crucial. The trig ratios that we cover, all six of them, sine, cosine, tangent, cosecant, secant, and cotangent. These trig ratios only work and apply whenever you're working with a right triangle. So if the problem doesn't specifically say, hey, this is a right triangle, then no, you can't use these trig ratios because you're going to get the wrong answer. And that's not really nice. All right. Trig ratios are basically ratios. Well, that's repetitive, isn't it? But basically they're fractions of the sides of the right triangles. Any two congruent angles of different right triangles will have equal ratios, and that's because they're congruent, okay? All right, let's keep on going, and I think I do have an example. Let's start off with something that you should have covered in previous math course. It says find the values of sine, cosine, and tangent for angle B. Well, if you notice, angle B is this angle right there, and we're going to use the Greek letter theta to represent angle B. All right, now, if you notice, I do have the hypotenuse, it's 33, and I have one of the legs, it's 18, but I'm missing a leg. Now, think about your skills. You should remember the Pythagorean theorem. That's going to come in handy. And that says that if you have a right triangle, a squared plus b squared is equal to c squared, where a and b are your legs and c is your hypotenuse. Now, it doesn't really matter what you label a and b, but it does matter that c is 33. So I'm just going to have a squared plus 18 squared equals 33 squared. And I'm going to give you a second to figure out what that is while I do the same thing. All right, so 18 squared is 324, and 33 squared is 1089. And so what I'm going to do is I'm going to subtract 324 from both sides. It's going to give me a squared is equal to 765, and then I'm going to take the square root, and so I'm looking at the square root of 765. All right, now, at this stage of the game, we're going to try and see, though, if we can simplify that radical. Remember, simplify means take out any square roots that might happen. And then just for the luck of the draw, I do know that 765 is the same thing as 9 times 85. And so I do know the square root of 9. The square root of 9 is 3, so I'm going to take that out. So A is going to be 3 on the square root of 85. And that will be my simplified value for A. So 3 square root of 85. All right. Now that I've found that missing side, I can label everything. Since this is my angle, then 18 would be my opposite side. 3 root 85 would be my adjacent side. And then 33, of course, is my hypotenuse. Now, if you remember, SOHCAHTOA, sine is opposite over hypotenuse. So sine of angle B would be 18 over 33, which ironically does reduce. You can divide by 3 and end up getting 6 over 11. So there's sine. Cosine is adjacent, which in this case would be 3 root 85 over hypotenuse, which was 33, which also reduces. I can divide by 3, and so that would give me the square root of 85 over 11. And then finally, tangent. Tangent is opposite, which in this case would be 18, over adjacent, which in this case would be 3 root 85. And then that can reduce as well. 3 goes into 18 6 times, so that leaves me 6 on the over the square root of 85. Now, one thing that you probably learned in last year's math is you never want to leave a radical in the denominator. So to get rid of that radical in the denominator, you would multiply top and bottom by that radical. So in other words, it would be times root 85 in the bottom and then times root 85 in the top. And so basically you'd end up getting 6 root 85 over 85. And so that would be the value for tangent. So those would be my 3 trig values. Sine would be 6 over 11. Cosine would be square root of 85 over 11. And tangent would be 6 root 85 over 85. All right, well, that should be good review from last year's math because you covered sine, cosine, and tangent then. So that's 3 out of the way, but if you remember, I said there were 6. We know sine, cosine, and tangent, but what about cosecant, cotangent, and secant? Well, let's talk about cosecant first. Cosecant symbol is basically CSC. And cosecant is the reciprocal of sine. So in other words, if you know what sine is, all you do is you flip that to get cosecant. So since sine is opposite over hypotenuse, cosecant is hypotenuse over opposite. All right, you're probably seeing where this is going. Since cosecant is the reciprocal of sine, guess what secant is? Secant is represented by the letters SEC, and you guess it, secant is the reciprocal of cosine. So, since cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. All right, the last one's not too hard to guess. Cotangent, which is represented by the letters COT, cot, is the reciprocal of tangent, so 1 over tangent. All right, well, since tangent is opposite over adjacent, then cotangent would be adjacent over opposite. So those are the values to find the ratios of cosecant, cotangent, and secant. All right, so let's look at a problem that asks us to find all 6 trig ratios. So it says, let's say that cosine of theta is 3 over 4. Well, here's the best thing you can do is draw a scenario of this situation. So obviously, since it's telling me that cosine of theta is 3 over 4, that lets me know that this is a right triangle, because remember, you can't use trig ratios in any triangle except for a right one. Doesn't matter where you put theta. I'm just going to put it in this corner. You could put it over there. Remember that cosine is adjacent over hypotenuse. So adjacent would be 3. So if that's my angle, then this would be 3. Hypotenuse is across from the right angle, so this will be 4. All right, so if you notice, I am missing a side. So the way I'm going to find that side is use Pythagorean theorem. So I'm going to have a squared plus b squared equals c squared. So in this case, I'm going to have a squared plus 3 squared equals 4 squared. That'll be a squared plus 9 equals 16. I subtract that 9, that gives me 7. Take the square root, and I just get the square root of 7. I know I can't simplify that, so I'm just going to leave it as the square root of 7. So that would be my missing side. Now that I have that missing side, I can write out all 6 of my trig ratios very quickly. Actually, I can go ahead and do sine. Sine is opposite over hypotenuse, so if that's my angle, opposite would be square root of 7 over 4. And since I know that sine is square root of 7 over 4, I can go ahead and say that cosecant is the reciprocal of that, or 4 over the square root of 7. Now, of course, you wouldn't want to leave it like that. You'd want to radicalize it, so then that's going to be 4 square root of 7 over 7. And so that would be my value for cosecant. All right, cosine's already given. Cosine would simply be 3 over 4. No guesswork here. The reciprocal of that would be secant, which would just be 4 over 3. And then for the last one, tangent is opposite over adjacent. So opposite would be the square root of 7 over 3. The reciprocal would be cotangent, which would be 3 over the square root of 7. but you wouldn't want to leave it like that. You'd want to radicalize it. So then that would be 3 square root of 7 over 7. And then that would be all 6 trig values. Let's look at one more. It says use Pythagorean's theorem to find the value of the missing side. Let's start there and then we can go continue from there. All right, so if you notice, I'm missing the hypotenuse. There's the angle that wants me to reference. So in this case, since this is my angle, opposite is 7, adjacent is 10, I need to find the hypotenuse. So I'm going to have 7 squared plus 10 squared equals c squared. So that's going to be 49 plus 100 is equal to c squared. So that's going to be 149. And then take the square root. So c is the square root of 149. And I'll go ahead and tell you that in this case, 149 does not simplify down any. So we're just going to leave it like that. All right, so now let's talk about each one of my trig ratios. Let's start off with sine. Sine would be opposite, which would be 7 over the hypotenuse, which would be the square root of 149. But you wouldn't want to leave it like that. You'd want to simplify it. So your answer would be 7 square root of 149 over 149. All right, cosecant would be the reciprocal. Now, here's my suggestion to you. Don't flip this one that you just got, because if you flip that one, you're going to get a radical in the denominator again. Instead, flip this one before you simplified it, and then that way you won't have a radical in the denominator. So if I flip 7 over the square root of 149, I'm going to get the square root of 149 over 7. And so that would be the simplified version for cosecant. All right, let's go ahead and talk about cosine. Well, cosine would be adjacent, which in this case would be 10 over the square root of 149. Don't want to leave it like that, so that's going to give me 10 square root of 149 over 149. Again, I wouldn't try and flip this one. I'd flip the first one. So the reciprocal, or secant, would simply be the square root of 149 over 10. All right, and then finally, I need to write out tangent. So tangent is going to be the good one. Tangent is opposite over adjacent. So tangent would be 7 over 10. And then the reciprocal of that, cotangent, would be 10 over 7. That's the hardest one out of all 6. Until I was being very, very sarcastic. Okay, guys, that's it for today's lesson. But in case you missed it, remember that trig ratios only work in a right triangle. There are 6 trig ratios, not just 3. So you're not just doing sine, cosine, tangent, but you are also doing cosecant, secant, and cotangent. Remember, cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. And when in doubt, always start off by using the Pythagorean theorem. You might not get your final answer, but it might help you get started.